Welcome back to Kafka Internal's Crashcasts. I'm Sheila, and with me as always is our Kafka guru, Victor. Today we're wrapping up our deep dive into Kafka consumers with an exciting topic: different consumer patterns. But before we jump in, let's hit our listeners with a brain teaser. Victor.
Absolutely, Sheila. I'm ready to challenge our awesome listeners.
All right, here's today's quiz question. In a Kafka consumer group with 3 consumers and a topic with 6 partitions, what's the maximum number of consumers that can actively consume messages simultaneously? Think about it, and we'll reveal the answer at the end of the episode. Victor, any thoughts on this question?
Oh, that's a tricky one, Sheila. It really makes you think about the relationship between consumers, consumer groups, and partitions. I'm sure our listeners will be mulling this over throughout the episode. It's a great way to tie in what we've discussed in previous episodes with today's topic.
Excellent point, Victor. Now, let's dive into our main topic. We've covered a lot about Kafka consumers in our previous episodes, including consumer groups, offsets, and handling failures. Today, we're looking at the various patterns we can use when consuming data from Kafka. Victor, could you start by explaining what we mean by consumer patterns?
Of course, Sheila. Consumer patterns refer to different ways we can set up and organize our Kafka consumers to read data from topics. These patterns help us design our systems to handle various scenarios, from simple single consumer setups to more complex distributed processing arrangements. The pattern we choose depends on our specific use case, scalability needs, and processing requirements.
That makes sense. So what's the most basic consumer pattern we should know about?
The most basic pattern is the single consumer pattern. This is where we have one consumer reading from one or more partitions of a topic. It's straightforward, but has limitations in terms of scalability and fault tolerance.
I see. So if I have a small application that needs to process messages from a Kafka topic, and I don't need high throughput, a single consumer might be sufficient.
Exactly, Sheila. It's like having one person responsible for reading all the mail that comes into an office. It works fine for a small office, but as the volume of mail increases, you might start to see bottlenecks.
That's a great analogy, Victor. Now, what if we need to handle more data? What's the next step up from a single consumer?
The next step would be using multiple consumers in a consumer group. This is where things get interesting. In this pattern, Kafka automatically distributes the partitions of a topic among the consumers in the group. It's like having a team of people to handle that office mail, with each person responsible for a specific set of mailboxes.
Oh, I see how that relates to our quiz question now. So, in a consumer group, Kafka ensures that each partition is read by only one consumer in the group, right?
That's correct, Sheila. This leads us to an important point. The number of active consumers in a group is limited by the number of partitions in the topic. If you have more consumers than partitions, some consumers will be idle.
Interesting. Are there any common pitfalls people should be aware of when using consumer groups?
Absolutely. One common mistake is not considering the number of partitions when scaling out consumers. If you have a topic with 4 partitions and you add 8 consumers to a group, 4 of those consumers won't receive any data. Another pitfall is not properly handling rebalances, which occur when consumers are added or removed from the group.
Those are great points, Victor. Now, let's move on to some more advanced patterns. I've heard about something called the fan-out pattern. Can you explain what that is?
Certainly. The fan-out pattern is when multiple consumer groups read from the same topic independently. It's useful when you need to process the same data in different ways. Imagine our office mail analogy again, but now we have one team sorting the mail by department, another team scanning it for digital records, and a third team analyzing it for customer trends.
That's a powerful concept. So each consumer group gets a complete copy of all the messages?
That's right, Sheila. Each consumer group maintains its own offset, so they can process the data at their own pace. This pattern is great for decoupling different parts of your system.
I can see how that would be useful. Are there any other patterns we should know about?
One more important pattern is the competing consumers pattern. This is similar to multiple consumers in a group, but it's typically used for work queue scenarios. Messages are distributed among consumers, and each message is processed by only one consumer in the group. It's great for load balancing and parallel processing.
That sounds like it could be really useful for distributing tasks across a cluster of workers. Are there any best practices for implementing these patterns?
Absolutely. First, always consider your partitioning strategy. The number of partitions affects how well you can scale your consumers. Second, be mindful of consumer lag. That's the delay between when a message is produced and when it's consumed. And finally, always design for fault tolerance. Consumers can fail, so your system should be able to handle that gracefully.
Those are excellent tips, Victor. Could you explain a bit more about consumer lag for our listeners who might not be familiar with the term?
Of course, Sheila. Consumer lag is essentially a measure of how far behind a consumer is in processing messages. If messages are being produced faster than they're being consumed, the lag increases. It's like falling behind in reading a constantly updating news feed. Monitoring this lag is crucial for maintaining system performance.
Thanks for that clarification, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. In a Kafka consumer group with 3 consumers and a topic with 6 partitions, what's the maximum number of consumers that can actively consume messages simultaneously?
Great question, Sheila. The answer is 3 consumers. Even though the topic has 6 partitions, we only have 3 consumers in the group. Kafka will assign 2 partitions to each consumer, allowing all 3 to be active simultaneously. If we had 6 or more consumers, only 6 would be active, 1 per partition, and any additional consumers would be idle.
Thank you, Victor. That wraps up our deep dive into Kafka consumers. To summarize, we've covered different consumer patterns including single consumer, multiple consumers in a group, fan-out, and competing consumers. We've discussed their use cases, benefits, and potential pitfalls. Remember, choosing the right pattern depends on your specific needs for scalability, processing, and system design.
Excellent summary, Sheila. In our next episode, we'll be moving on to a new chapter, Message Delivery Semantics. We'll be exploring the concepts of at most once, at least once, and exactly once semantics in Kafka. It's going to be fascinating.
I can't wait, Victor. And to our listeners, thank you for tuning in. If you've enjoyed this episode, please subscribe to Kafka Internal's Crashcasts and leave us a rating. Your support helps us continue creating in-depth educational content about Kafka. Until next time, keep streaming.